guys, welcome back. This is Miss Carasolas. I am doing the Unit 9 review, which can be found on Schoology, so just head there to get the questions, and then I'm going to walk through all of them. This review is only 12 questions. Your test is 20 questions. The first 10 will be expanding and condensing. The next 10 will be solving. So as long as you do this review, you should be fine. Also, make a note that you do need your property rules. So just make sure you write those down on your chart that you are able to use on your test. Here we go. Number 1, condense into a single log. That means that I want the word log written one time. So I'm going to have, and they have to be the same base, which these both are base 2, base 2. So let's go ahead and rewrite log base 2, 14, plus log base 2, 32. Sorry about that. Okay, so remember, first thing we are going to look at is our power property rule, which tells me to raise any number that's on the outside up. So we're going to do log 2, 14 to the power of 3, plus log 2, 32. Next is product property. So log 2, 14 to the power of 3 times 32. We just condense them further. Next, I'm going to go ahead and actually solve 14 to the power of 3 times 32. So if you have a calculator in hand, that'll be quick. So my final answer is log 2. You don't have to put parentheses, but you can if you want. So 87,808. Final answer. We are good to go. So on to the next one. Okay, same process. So condense into a single logarithm. So this time we have 1/3 log 3, 125 minus 1/2 log 3, 49. So let's go ahead and raise these to powers on their numbers. So log 3, 125 to the power of 1/3 minus log 3, 49 to the power of 1/2. And you're pretty much just taking the cube root of 125 and the square root of 49. So log 3, 125 to the power of 1/3. The minus sign tells us divide. 49 to the power of 1/2. And if you want to do the top then the bottom in your calculator and then divide them, that's fine. Or you should be able to put the whole thing in your calculator. And you end up with log base 3, 5 over 7, which you can put in parentheses. You don't have to, but that is your answer. Next. Okay, same thing. Condense into a single logarithm. We have 3 log base 4 a to the power of 5 plus 2/3 log base 4 b 9. So let's go ahead and move our big numbers up top. Remember, when we're moving these and there's already exponents, you're multiplying. So we're going to have log base 4, 3 times 5, a to the power of 15. Plus, we have log base 4, b 9 times 2/3. We can do 9 times 2/3 off to the side. So 9 divided by 3 is 3. 3 times 2 is 6. Okay, and then using using product rule, we are multiplying, so log base 4, A15 times B6. And because those are not common variables, we are done. Next problem. Okay, now we are going the other way. We're expanding. So here we go, expand each logarithm. So we have log base 2, w raised to the power of 6. Okay, the only thing we can really do here is power rule, which tells us to take our exponent and put it out front. So 6 log base 2 w. And that is it. Next one, we're going to go to expand this logarithm, log base 3, 25x. So because I have 25 and x next to each other, I know that's multiplication. So I'm going to do log base 3, 25 times x. Okay, so I am doing log base 3, 25 plus log base 3 x. Okay, and then that's pretty much it. You can break the 25 down further if you want. However, I'm not going to give you more points for that, so this is really it. Let's go ahead to the next problem. Okay, we have a fraction as well as a cube root. So remember roots. We have square roots is 1/2 as an exponent. Cube root is 1/3 as an exponent. And fourth roots are 1/4 as an exponent. So let's go ahead and log. Since I don't have a base, it's base 10. I'm going to put x5 over y7 raised to the power of 1/3. Okay, so you can do this multiple ways. I'm going to go ahead and give each exponent a 1/3 by multiplying it. So x to the power of 5 times 1/3, and then y to the power of 7 times 1/3. So on top, I end up with x to the power of 5/3. On bottom, I end up with y to the power of 7/3. Okay, division means to subtract. So let's go ahead and log minus sign. We have x to the power of 5/3, y to the power of 7/3. Okay, now we've got power rule, which tells us move those out front. So 5/3 log x minus 7/3 log y. And that is my final answer. Okay, you could have also at the beginning used power rule to bring down the 1/3 and then just expand, and then 1/3 times 5, 1/3 times 7. It would have given you the exact same thing. Next, we are moving into the solving portion of this test. So remember, you might need a calculator. Also, remember the one-to-one property. If we have two logs, one on each side of the equal sign with the same base, they can cancel out. So right here, we actually need to condense because we have too many logs. We have a log here, here, and on the other side. So we need to make this one log. So this is a plus sign, which is 3x minus 12 times 2 equals log 3, 5x. So let's go ahead and cancel out these logs. because there's one on each side. I'm going to rewrite 2 3x minus 12 like this equals 5x. So next we're just doop, doop. So 6x minus 24 equals 5x. Move variables to one side, constants to the other. So I'm going to minus 6x on both sides. I've got negative 24 equals negative 1x. Divide by negative 1, divide by negative 1, and we get x equals 24. So let's move to the next one. Okay, solve the logarithm. 2 log base 4 to the power, or 3x minus 12 equals 4. Several ways you could do this one. I am going to condense this down to isolate the log. So I'm going to get rid of this 2 first on both sides. So log 4, 3x minus 12 equals 4 divided by 2 is 2. And then I'm going to go ahead and convert this. So convert to exponential, which remember is just you start at your base, go around the equal sign. So 4 to the power of 2 equals, back around your equal sign, 3x minus 12. Okay, so what is 4 to the power of 2? It is 16. 3x minus 12. So then I am doing plus 12 plus 12. So 28 equals 3x. And this is not going to divide nicely, so we're going to leave it as a fraction. So x equals 28 thirds. We can't simplify. On to the next. Okay, so solve each logarithm. This one is super similar to the last one in terms of it's got one log on one side and a number on the other side. Okay, so we have 1/2 log base 6, 5x. So we're gonna go start at the base, go around the equal sign. So 6 to the power of 1/2, back around the equal sign, equals 5x. Okay, so 6 to the power of 1/2, or the square root of 6, doesn't really give us a nice number, so let's go ahead and divide by 5 on both sides. Type that into the calculator, and let's round. I'm going to go ahead and say to the nearest hundredth. So we've got x equals 0.49. Okay, final answer. Let's go to the next one. Okay, so this one we've got 3 logs. So we do need to condense this side first. And then we can use our 1-to-1 property, which tells us to cancel logs of the same base on both sides. So log, so we've got log base 10, 12 divided by 6 because it is a minus sign, log 3x. Okay, we can cancel out our logs. So 12 divided by 6 is just 2 equals 3x. Divide by 3, divide by 3. Let's go ahead and leave this as x equals 2/3. You could have also turned that into a decimal if you want, but it is repeating, so it's not going to be a nice decimal. On to the next. So solve each logarithm. 12 to the power of x minus 3 equals 5. So remember, in order to get that variable out of the exponent spot we want to log both sides. Okay, so when I do log 12, x minus 3 can actually come to the front using power rule. Was log 5. Okay, now I want to isolate x, so I'm going to go ahead and divide by log 12 on both sides. 12 x minus 3 equals log 5 divided by log 12. You definitely might want a calculator for this. We're going to plus 3 to both sides. And we're going to type that in our calculator, log 5 divided by log 12, or log 5 divided by log 12 plus 3. And we get a decimal, which we're going to round to the nearest hundredth, so 3.65. Okay, next and last, actually. So we have our using the change of base rule, which tells us log BA, base A. We can do log A divided by log B to get our answer. And let me just double check that. Make sure I'm not saying this formula the wrong way. So change of base, log BA, log A over log B. Yeah. Okay, that's why it's really important that you write down the rules and you're good to go. So we're just gonna do log. This is B, this is A, so log 24 divided by log 6 should give us a decimal. So I put x equals, but you don't have to put x equals. You can just write the number. Okay, and it is 1.77, rounding to the nearest hundredth. And that's it. Good luck on your test.